Okay, in this video we're going to be looking at section 7.4, similarity and right triangles. In a right triangle, what is the relationship between the altitude to the hypotenuse, triangle similarity, and the geometric mean? The altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. If I have a right triangle and I draw this altitude right there, then I've taken the big triangle, broken it up into two smaller triangles, and all three triangles are going to be similar. Okay. What is the geometric mean? The geometric mean is the number x such that this proportion is true, where a, b, and x are positive numbers. Another way to look at this is if, because I can cross multiply, if x squared equals ab, then x is the geometric mean. And so let's look at an example and see how we can use this knowledge to our advantage. So here I have a triangle. PQR is similar to QSR. So PQR is similar to QSR. So what is the length of PS? Okay. Well, what I know, okay, is if they are similar, then corresponding parts, okay, are proportional. I have, this is an altitude, so I know not only is the big triangle similar to the smaller triangle, but it's also similar to this triangle over here where PS is at. So let's try and find the corresponding parts. One of the things that might be helpful is you can split the triangles apart, so you can see all the right triangles and then the corresponding pieces. So here is one methodology for solving this. This is what I did. I started off by finding this length first, right here. So if I look at this, this is the hypotenuse of the small triangle. This is the short side of the small triangle. This is the middle side of the small triangle. This is the middle side of the big triangle. This is the short side of this big triangle, and this is the hypotenuse. So we're taking off what we know here. Here's some of the proportions that I noticed. I know that QR to SR is proportional to PQ to QS. QR, SR, hypotenuse, small side of this middle triangle, is going to be proportional to PQ, which is the hypotenuse, and QS, which is the short side of this triangle. So that's why they are proportional. And then this allows me, when I plug in my numbers, to find QS. So doing QS here, I can take this and I can solve this for QS by cross multiplying those, multiply together, divided by that number right there. So it gives me 9 times 20 divided by 15, and then this reduces down to 12. So this length is now 12. Finding some other ones that incorporate this side now, okay, allows me then to come up with this proportion, PQ to QR, PS to QS. So let's take a look at those and see which ones those are. So PQ is the middle side of the big triangle, and it's also the hypotenuse of the middle one. QR is the short side of the big one. PS is the middle side of this triangle right here, and QS is the short side. So we're going hypotenuse, long side to short side, and then here is long side to short side. So that's why those are proportional in that fashion. Plugging in the numbers that we know, 15 and the PS is what we're looking for. And then I can solve this for PS by multiplying the diagonal and dividing by the third. And so PS is 20 times 12 over 15. And then this allows me to reduce a little bit easier and gives me 16. This is why I don't multiply things out like this, because then I know I'm going to be reducing. It's easier to see what can reduce. It makes it a lot easier to do without a calculator. Okay? So that is one way, and we just found what PS is equal to right there. Okay? And this is just one methodology. There are other ways to do this problem. That's just the first one. Okay? Let's look at another example and see how that might assist us. So here I have this. What is CD? So CD is this piece right here. Okay? So what you notice here, and this one uses that concept of the geometric mean. My picture isn't drawn perfectly, so it's a little harder to tell. But this is the short side of this triangle. This is the long side of this triangle, hypotenuse. But over here, this one right here is the long, and this one's the short. So I can set up a proportion. 5 is to this side. Okay, so this is the short side, middle side. But on this triangle, this is the short side, and this is the middle side. So then the proportion looks like this. 5 is to CD as CD is to 15. And you can see that CD is going to be what's called the geometric mean. And so I can cross multiply here. I'll get CD, whatever that value is, squared equals 5 times 15, which is 75. So the length of CD is the square root of 75, which we can simplify as 5 times the square root of 3. Okay? So let's take a look at some other information that might be beneficial to us in right triangles. So this right here is showing you exactly what we just discovered over here. And so the length of the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So if I draw the altitude of a right triangle, then the altitude will become the geometric mean of these two pieces. Okay? And so that's a way to go directly to this, because this is something that you see quite often in standardized tests and things like this geometric mean concept. And so this divides this hypotenuse into two pieces that I can set up into the proportion here. And this becomes the geometric mean, which means it's the same in both parts right there. And this allows you to go to it directly. So note, the main thing to remember about all these rules that I'm giving you, okay? Instead of trying to memorize them all, which is almost an impossible task to do, that you'll never remember them for very long anyway, it's just to remember, once you have similar triangles, the corresponding sides are proportional. So you can just set your proportions up whichever way. Just make sure that they are all consistent, okay? Corresponding sides proportional means you have to go from the same position. For example, since I know these things are proportional, I could have done this problem here and gone 5, and set up in a little bit different fashion than these things. Okay, and so that's something to keep in mind as you go through this process and stuff like that. So remember, once you have similar triangles, corresponding sides are proportional. That's what you're looking for. So here's a couple more examples we can look at. So here's one right here. I have this information. So what we know so far is we already know that this right here will be the geometric mean of these two pieces right there. So we can actually find those if we wanted to. Okay? Or we can go and try and find JL directly. So JL is this length right here. So what is this length in this triangles? In all the triangles? Well, it's only in two triangles. It's in the big triangle and it's in the little triangle. In the big triangle, it is the short side. In the little triangle, it is the hypotenuse. Okay? And so we can use this to help us figure out some of these things. So if I want JL, can I use this stuff to help me see what I have? Well, I have the short side in the little triangle and the hypotenuse in the big triangle. So let's set things up. In the small triangle, I can do hypotenuse to short side. In the big triangle, I can do hypotenuse, which is 24, to short side. And you'll notice that you have that geometric mean set up. So this then, and I just did it by side pieces, okay? I didn't have to go hypotenuse to short. I could have gone short to the hypotenuse and it would have looked just like the one that did, but this is basically how it works. You cross multiply, so I have JL squared, and this is 4 times 24. You can actually multiply that out if you want to, is 96. And so JL is the square root of 96, which you can then simplify as 16 times 6, which gives me 4 times the square root of 6. Let's look for KL. Find KL. KL is right here. So what position does this play? Well, this is the hypotenuse of the middle triangle, and this is the long side. Okay, so let's look for another one. Okay, this was the hypotenuse and the long side. In the big triangle, this is the hypotenuse and the long side. So I kind of like I'm looking for the long side, and this is what I'm looking for. So then I can just write that out. So hypotenuse to long, hypotenuse to long, and then the big triangle, hypotenuse to long. That's how I do proportional for similar triangles. Then we have KL is whatever 20 times 24 is. And then KL is the square root of that. And you can multiply that out. 2 times 24 is 48, so this is 480. And then we can simplify this radical right here, and you're going to get 4 times the square root of 30. And so that's how I can use what I know for this, okay? The thing to remember here when I pick the square root right here, little side note for you, is when you take the square root of both sides, was what I did right here, you're supposed to have a plus or minus in front. But because we're talking about side lengths can only be positive. They can't be a negative length. So that's why we only have the positive values here. But please note that there is supposed to be a plus and a minus out in front. So here's our last example. It's more of an algebraic thing to help us answer. But we use the same process. Find x, y, and z. So we come over here and we find some portions that we can use. Now I already know that the altitude will break the hypotenuse of the big triangle into a proportional concept with geometric mean. So I know, based off of this, that I can take this right here and write 6 is to x, so that is to that, and then that is to that. Okay? And so so 6 is the long side, this is the long side, so this will be x plus 5, and then long to short, long to short. Long to short, long to short. That's how I determine my proportions. When you have more than one term in a fraction system like this, make sure you always put it in parentheses, okay, so you don't make any sign errors. When I cross multiply, I'll get x times x plus 5 equals 36. We need to distribute, bring everything to one side because we have a quadratic. You need to make it equal to 0. Once you have a quadratic, you need to factor or use the quadratic formula. Factoring is much faster. Any factors of 36 that will subtract and give me a 5. And we know that's 9 and 4. This is plus, this is minus to make all this happen. And then what is the 0 from here? When x equals negative 9. What is the 0 from here? When x equals 4. So we're saying that this x value right here is negative 9 or 4. Well, x represents a length. Okay, this whole section, this length right here is x. So it cannot be that one because the length cannot be negative. That means x is 4. Okay, we come over here now, we have these values. We can come in here and figure them out and find these other values. So this is a 4, this is 9. We have those numbers now. We don't need to use x's anymore. And we want to find y. So we look for the comparison here. Y here is a hypotenuse. this is a short side. In the big triangle, y is the short side, and this is the hypotenuse, which we now know is 13. So we have y is to 4 as 13 is to y. And then we can cross multiply this, and we get y squared equals 4 times 13, or 52. And when I square root both sides, I'll get the square root of 4 times 13, which we can see simplifies to 2 times the square root of 13. Do z the same way, compare and find what we know and relate it to. So z is the middle side of this big triangle. Okay, it's also the hypotenuse of the middle triangle here. This is the long side. So z is the long side of the big triangle and the hypotenuse of the middle triangle. So z is also the long side of the big triangle, and this is the hypotenuse here. So there's your connection. Z is to 9 as 13 is to z. Hypotenuse to long, hypotenuse to long. And this is going to be 9 times 13. And so z is the square root of that. And so z is 3 times the square root of 13. And so that's how I can use proportionality, similar triangles, to find values on a triangle. All right, we'll do more together in class, and this concludes the video.